So yes, this is double linked list. As you can see, instead of the single linked list, as in the linked list, single linked list, there were two portions of the link node here. First was data part and another was the pointer part, which was pointing to the memory address of the next element. So in this double linked list, we have basically, instead of a single pointer, we have two pointers here. One is having the memory address of the previous node, and the next pointer is having the memory address of the next node here. So the memory address is 100 here, second node memory address is 200, third node memory address is 300, and fourth node memory address is 400. So first node's next will have the memory address 200, and second node's next will have the memory address of the third, that is 300. Third node next pointer will have the memory address of the next element, that is 400 here. Similarly, the fourth elements, fourth element's previous will have the memory address of the previous node. Third node's previous node will have the memory address of the second element. Second node's previous will have the memory address of the first element. So this is the double linked list. And apart from the links, there are two more pointer variables here. One is head, which is having the memory address of the first element, and tail pointer variable, which is having the memory address of the last node, right? And apart from them, the first node's previous pointer will have null, and the last node's next pointer will have null, right? So again I am repeating, next pointer will have there are two pointer variables here. One is previous pointer, another is next pointer. Next pointer will have the memory address of the next element, that is 200 here. This element, next pointer, will have the memory address of the next element, that is 300 here. This element will have the memory address of the next, this next pointer will have the memory address of the next element, right? So this was regarding the next is same as in the single linked list. So this is the previous pointer here. Previous pointer of the last element is having the memory address of the second last element here, that is 300. 300 is stored in the previous pointer of the last element. Then the previous pointer of this node is having the memory address of the previous node here. Again, previous pointer of this node is having the memory address of the previous element here. So previous pointer points to the memory address of the previous node, and next pointer points to the memory address of the next node, right? And apart from them, the previous pointer of the first node will have the value null. Similarly, the next pointer will have the next pointer of the last node. Next pointer of the last node will have the value null here, right? Again, there are two pointer variables here. One is head and one is tail. Head will be pointing to the first node here, and tail pointer will point to the last node here. So that was all regarding the double linked list. So now coming on to the first operation, that is traversal. So traversal is two ways. First is forward traversal, second is backward traversal. Forward traversal is when we are starting from the first element. We are displaying all the data values here. We are traversing from the head and we are traversing to the last. That is known as forward traversal, right? And backward traversal is we are starting from the last element and we are going towards the first element. That is known as the backward traversal, right? So for forward traversal, obviously we require head, and for backward traversal we require tail here, right? For forward traversal, we will make use of next pointer variable here. Let me write also. For forward, we require head here. For backward, we require tail here. For forward, we require next pointer to move towards the next element, and for backward traversal, we require pointer variable, that is pointer that is previous here. In the case of forward, we start from head and we go till the pointer of the last element is having the null value. And in the case of backward, we start from tail and we move up till the first element. How we will know that this is the first element? Where the previous pointer will have the value null, right? So let me take the cases again. So let me do the forward traversal and backward traversal algorithm part. Forward traversal is exactly the same as in linked list. See, first here we will take a temporary variable here. Temp, and it will point to the first element in this node, that is head. It will also have the memory address 100. So now both head and temp are now pointing towards the first node in the linked list, that is 100, right? So now I will go on this traversal up till the last element. So how I will go? I will first take the temp to be equal to 100. Then I will display this temp is now pointing to this. So I will display the data part here. How will write it here? Display temp data of temp. Cout temp data of temp here. So after displaying temp of data, that means 1 will be displayed here. I should move towards the second element. So how I will go? With the help of next pointer. Memory address is 200 and 200 memory address is stored in the next pointer. So I will update the value of temp. And instead of 100, I will write here 200. I will get 200 from this pointer position. That means temp is equal to temp arrow next of temp. So next of temp is 200, so this will point to this. Again it will be updated to 300 I will get from next here. So temp ka next is 300, so temp will point to here. Similarly it will point to here. So now this next part will be having the value null. That means we have already reached the last element. Once we reach the last element, this condition is false, so we are out of the loop. So all the elements are displayed now. So this is known as a forward traversal, right? So let me now move towards the backward traversal. Just take a minute. Right, so for backward traversal, again take a temporary variable here. So now in this case, instead of this pointer variable pointing to the first element, I will make this pointer variable to point towards the last element, that is, it should also have the memory address 400 here, and from where I will get this 400? From this tail pointer. So now both tail and temp will point towards the last element in this linked list. Again the same steps, but instead of next pointer here, I will use here previous, right? But before using previous, I will display the data part here. So cout temp data, cout temp data. After cout, after displaying the data part of temp, I will move towards the second last element. To move towards the second last element, I need to get the memory address here. So memory address is 300. From where the 300 will be is going to be stored in the previous part here. So I will write here updated value of temp is equal to temp ka previous. So temp ka previous 300 is stored in this previous pointer position here. So that value of temp has been updated. Now this is 300 and then temp will point to this, right? So similarly again the value of temp will be updated. Now this will be equal to 200 and this will point to this. Again the value of temp will be updated. This will come to 100 and this will point to here. So once we reach here, temp ka previous becomes equal to null. Now temp ka previous becomes equal to null, so we are out of this loop now. So that means all the elements have been traversed. The output will be equal to 4 3 2 1. So that was backward traversal. You just have to keep this thing in mind. Instead of temporary so in this case temp will point towards the tail position here instead of head. The value of temp will be updated with the help of previous pointer here, right? So that was all regarding the traversal.